Hello everyone. Today's video is not very explaining how something works specifically. I'm just going to be applying some of our knowledge from statistics into something that interests me and showing you guys what I got as my results from it. And I'm going to be explaining which one of the Dungeons and Dragons ability score deciding methods is the best statistically. And I have already done this, and it is quite interesting to see how it works. You can follow along too if you like, and you can even try to calculate it yourself. But I'm just going to go over which method is the best based on the statistics. So D&D is a game which you can play, a tabletop RPG, and it involves having 6 different abilities, and these abilities determine how you play. Now you don't need to know any knowledge about D&D, all you have to know is that you have to decide these 6 abilities, and they'll usually vary from 0 to 20. And the higher the value, the better you are at some sort of ability. Now, if you want to be the best character in the game, you want to have the highest abilities out of everyone. So, and there are 3 different ways to decide these abilities, so which one is actually better than the others. So, I'm just going to quickly give a rundown on what the 3 different ability deciding methods are, and then we can see and analyze which one is the best. The first method is the standard array, which is just you get these 6 numbers, and these are your ability scores, and you can place them in whichever ones you want. You'll put the higher number and the ability you're going to use more based on your character's type. But then, so the numbers are 8, 10, 12, 13, and 14, and that's all. You just have to plug these numbers in. It's a very quick and effective way to decide a character's abilities. You don't spend time having to figure out what your scores are. They just give you this set and you place them however you want accordingly. So it's a quick and easy way. A lot of people like it just by how effective it is. The next method is the random generation. Before I did any of the statistical calculations, this is the one I always like to use because it was very exciting and thrilling, and there would be a lot of different values you get. What you do is you would roll 4 6-sided dice. This is the notation I'm going to be using, where D stands for the dice, the number after is how many sides the dice has, and the number before is how many of these dice are you rolling. So it works by rolling 4 6-sided dice, subtracting the lowest value, and then adding up the remainder. So for example, you might have 3, 2, 6, and 5. And these are the numbers that you rolled. So you would take away the smallest one, which is the 2, and then sum up the rest. So this would end up giving you an ability score of 14. And then you would have to repeat this method for the other 5 ability scores too. And then that would help you decide what your values would be. The third method is the point cost system, where you have 27 points and you can spend them to get 6 different abilities, and the higher the ability, the more points it costs. So this allowed you to decide how much you're going. If you really want so many high values, then you would know that you'd end up with lower values for the other ones. If I were to spend a lot on getting very high points such as 15, then my lowest, then I might end up not having enough points to get high values for the other scores, which would mean I'd have to use lower values for my other abilities. So now let's see which one is actually the best statistically speaking. To do this, I'm going to be looking at the mean, the median, and the range of values. I will be using the mean and the median to help compare to the other values, and the range will tell me how many different values I can really have. So some combinations might allow for you to have a large variety in your values, so some really low and some really high, or maybe they're all very similar, and that'll depend on the range. Let's figure out what the mean, median, and range for each value is. Alright, so here we have the standard array, the very first method, which has these 6 different values, and let's figure out all of its important data that we can use in order to compare it with the other methods. So the first one's the mean, and for a simple set of data like this, it's quite easy to calculate the mean. All we would have to do is the sum of all of the data divided by the number of data. So we can calculate this quickly and see that if we sum up all the values and divide by 6, we get 72 divided by 6, which is 12. So the mean of all of our data would just be 12. The median of S would be the middle value. Now, because these values are already sorted for us, we just have to take the middle one, which is here between 12 and 13. So we'll take the average of 12 and 13, and that is 12.5. To find the range, we would just take the maximum value of S minus the minimum value of S, which would be 15 minus 8. And that gives us 7. So that is the information related to the standard array. And we're going to use these values to compare them to the other values later on. So I'll take a note of this and let's move on to the next method. The next method is the random method, where we had our 4 different dice, which are 6-sided, and then we sum them all up together minus the smallest value to get our randomized value. But how could we calculate the mean, median, or range for this set of values? So to do this, I was not able to find a very effective method mathematically that would help me to find the mean. So instead I created a small Python program to calculate every single combination that you could roll with these 4 different 6-sided dice, and then to find the mean using that. I also asked it to find out how many times each different sum appeared, so that I could have a table of data and use it to also find my median. I will have a picture up of this data, and we can use that data in order to find out what the mean, the median, and the range is. So because we have 4 different dice that we're rolling, and each of them has 6 different possible outcomes, that means that in our list there's a total of 6 to the power 4 possibilities, which is why it was very handy to have a computer test and run every single one of these possibilities. Now, after my Python code did the test and it got the sum for every possibility, I told it to add all of it up and divide it by 6 to the power 4 in order to get a mean value for all of the different possible outcomes. To find the mean of the data, the computer found out that if you sum up every single possibility, you would get 15,869, and then we would just have to divide that by 6 to the power 4 to get approximately 12.245. So this would be the mean of our randomized data. Of course, do take note that this is randomized information, which means that it doesn't mean you're guaranteed to get an average of 12.245, but we will discuss this more later on when we are comparing and looking at how accurate our results actually are. The median of the data would be the middle value if we sorted it all from the smallest to largest, and that would be the 6 to the power 4 divided by 2 values. So that's going to be the 648th value in our list of all possible combinations. So we can look at the list that the computer gave me in my Python code and see in which category would that fall into. And we would see that the 648th value, when sorted in order, would be in the 12th section. If we're looking at the frequency and how often each value appeared, the 648th value is the 12th. It has a value of 12. So that means that our median will be 12. So to find out what the range was, because each combination was different, I decided to take the largest possible combination, which would be getting all 6s on your dice, subtracted by the smallest combination, which would be getting all 1s on your dice. So if we were to apply our rules of summing all of them up and subtracting the smallest, we would end up with 6 plus 6 plus 6 plus 6 minus 1 of the 6s would give you 18, and 1 plus 1 plus 1 plus 1 minus the smallest value, which is 1, would give you 3. So that means that our range for the randomized data is 15. So these are the values that I will be using. Once again, of course, we can, this is randomized information, but we will discuss the accuracy of my readings later on. The next option is the point cost system. Now the point cost system is interesting because it allows you to pick your values. So in the end, to calculate the mean, the median, or the range would completely depend on what you would choose. So what I'm going to do is I'm going to find the mean of each possible combination. So the mean of the mean of the median, and the mean of the range, and use that data. Thankfully, I did find someone on Reddit who managed to find all the different possible combinations you can use with the point cost system, or at least most of them, but I will be using their data in order to find out what my values would be. The Redditor said that there are a total of 65 list possibilities, so I used those values and I put them into a table. And after finding what the mean and the median and the range for each possible list was, I then took a mean or an average for each of these possible values. So that ended up giving me a mean of 12.054 approximately, a median of 12.169 approximately, and a range of 5.431. However, depending on what you pick, of course, each of these values changes, but that's also true for the randomizing option. However, I used the largest possible range for the randomizing option, so instead of using the mean range, I will be using the largest possible range to keep my values all on the biggest possibilities. And the largest possible range that I found in my data was 7. So this is our information for the point cost system. What's interesting to note too is that in the point cost system, in the list that was provided, one of the list items was the standard array. So the standard array can also be made using the point cost system, which might be something nice to know. And here are all of our results in the end. Now we can see that clearly when D&D, the creators, were trying to make these rules, they did try to keep them quite close possible, which shows that it is quite fair. So no matter which method you choose, you are likely to get very similar results. However, here we can see that the mean of the randomness is the largest, which means on average you do get a larger value with your randomness. However, the randomness also has the largest range, which means that because the randomness can go from a minimum of 3 to a maximum of 18, however, both the standard and point cost only go from 8 to 15, which means that it's quite a high risk, high reward scenario for the random option. The medians are also quite similar. However, in this case, the standard array has a highest median, but it's also the safest option. But then what we can also do, because we learned in statistics a way to measure the skewness of our data. Now, there is a formula for the skewness of our data, which is 3 mean minus the median divided by the standard deviation. However, I did not calculate the standard deviation for this data because there are a lot of possible combinations and it might have taken very long. If you do want to try it, I would like to see what you get in your results, so please do share. We can also measure the skewness of the data based on if the mean or the mode is bigger, so we can tell if it's positively or negatively skewed. And these are our rules to understand that. When the median and the mean are the same, there is no skew, and data is evenly proportioned. When the median is less than the mean, then it has a positive skew, but when the median is greater than the mean, there's a negative skew. Now, we know that data which has a negative skew means that it has an overall higher value, so we can use that to compare. So let's find out if these have positive, negative, or no skew first. So then here we can see that the standard array and the point cost method both have a negative skew, where the standard array has a greater negative skew than the point cost because the values are much closer together. But the random option has a positive skew, which means that the values on average are slightly less, but that might also be because there are a lot of possible combinations. I'm not sure if this would work completely, but this does give you some data and some information on which method to use. In conclusion, in my opinion, all methods are quite equal and quite similar. However, for me personally, I would always choose the random method because I do enjoy having the thrill of having a large variety of numbers. Sometimes I get really lucky and I get a lot of good values, but then I might also have one ability which just gets really, really low, and then it does make it much harder to play as a character. So the standard array is always probably the safest option, and it's quite nice and easy to go with. But the point cost method is quite good too if you're willing to think what would be the best way to distribute my abilities, which is a nice one where you have to think about it actually, and it's up to you to figure out if your character is going to be strong or not. For the rest, I'd say all these methods are quite good, and they do work well. And yeah, that's just a great way to apply and use our knowledge of statistics in the outside world. So I hope that you guys did enjoy. And if you managed to learn something new or you have changed your opinions on a certain method, then please feel free to tell me. Of course, if there's any other changes or adjustments that you notice in my calculations, please feel free to mention that. Or if you calculate a standard deviation or got different results from me, then it would be interesting to compare on what we did differently. All right. Any of the different resources like my Python code or the table of values that I used, I will link below so that you guys can access it if you would like to take a look. And yeah, thank you very much. Have a nice day.